You're welcome back. So in this example, we will look at, I think, more complicated questions where you have both horizontal shifts and you have a vertical shift. So what do we do in this situation? We just still the same procedure. We try to go for the helper first. And so what will be the helper in this case? Our helper is just going to be a half. Since this is cosec, then it means we have to go forward. Cosine pi x plus pi over 2, then minus what? Minus 3. So here we get our parameters. This is going to be, amplitude is going to be minus, which is just going to be half, right? The period is 2 pi by k, so which is just 2 pi over what's over pi, and this is equals to 2. We have a horizontal shift, which is x is equals to minus b over k, right? And what is b? Here you can see this is our a, this is our k, this is b, and this is what? C. So this is minus b is what's pi over 2, okay? Then we divide by what? By k, and what is k? K is pi. And this is just going to be minus pi over 2 times what? 1 over pi. And this is just going to be minus half. So we have a horizontal shift of minus half, right? Now, what do we need? We also need to see that what will be the range of the graph. You know, it's going to be absolute value of a plus c. Then this will be the range in this case because we have a vertical shift of what? Of c is equals to minus 3. So this will give us minus absolute value of a. So this is just going to be, we already have a. So this is minus half, minus 3. And then we have half, also minus 3. Okay, this we can write it as minus half, minus what's 6 over 2, right? And this is also half minus 6 over 2. So in other words, it's just minus 7 over 2. So let's do this one. Let's remove this. So minus 7 over 2. And this is minus 5. Minus 7 over 2 minus 5 over 2 will be our range. Okay, now another thing we need to know is what is our interval? How are we going to plot the graph? But since you can see the period is what, this is one way to do it. The period is what, 0 to, originally it's supposed to be from 0 to 2 now, because that is our period, which means that we have to partition 0 to 2 into 4 intervals. So the midpoint is going to be half. This is going to be 1. I mean, this is going to be half. And this is going to be 3 over 2, right? But because we have now our horizontal shift, yes. What is our horizontal shift? Look at our horizontal shift. It's minus half. And this means to the left, yes? So it means we have to remove half from each of these points. Now, once that is done, you see now that we will be dealing with which interval. So let's come here now. So 0 minus half, it means we will start from minus half. Half minus half, this is going to be 0. 1 minus half, this is also half. 3 over 2 minus half, and this will be 1. And then 2 minus half, this will be 3 over 2. So these are the 4 intervals we'll work with. Here, this is our x-axis, right? The y, yes, this is our y-axis. So, but here now you see that we have a vertical shift of -3. So it means that our baseline what is the baseline? The baseline is at where? At -3. So let's say this is -3. Now, what is our minimum value? Our minimum value is this one. This is our minimum value. This is our small m, and this is our capital M. So this is -7/2, which is like -3.5. So let's put it here. Let's say this is -7/2. Okay. And the maximum value is what? Is -5/2, which is about 2 point something. So let's put it here. So this is -5/2. Okay. All right. Now I think we are ready to sketch this. Okay. So remember, we are sketching the graph of sine. If you're sketching the graph of sine, so it means we're going to start from the baseline. So remember, this is our -half is our starting point. So it means at -half, we're going to be on the baseline, which is -3. Then when we move forward to 0, we're going to go to the what? To the maximum. So since there is no reflection, and what is the maximum is this point. Then if you move forward again, at half, we should be back to the baseline, which is -3. Then at 1, we will go to the minimum, which is -7/2. Then we will back to the baseline at this point. So this is just going to be something like this. This one. Right. Okay, now we need to know what are the vertical asymptotes. So we don't need to think too much. The vertical asymptote are just the what? They are the zeros. So the zeros will be just this point where the black graph cuts the what? The x-axis. So these are this and also here. And then we will have another one here. Right. Okay. So now it means the graph that we required will be the popular one, which I'm about to sketch. All right, so this will come here. This will curve down here. And then the same thing here. Okay, so the purple one is actually the graph that we need. So that is the graph of what? Of half cosec of pi x plus pi over 2 minus 3. So let's go to the next one. Okay, the question is asking for so many things. So it says find the period, the horizontal shift, the range. So let's talk about the range. So this is actually the range. We have the range already. But now this is not the range actually. This range is for the range of the helper graph. So we need to talk about the every other thing remain the same. The vertical asymptotes. So these are the vertical asymptotes here. These are the vertical asymptotes. And then we can talk about the range. So what will be the range of the graph? As you can see, the range of the purple graph is from where? It's from minus infinity to what? To minus 7 over 2 close union minus 5 over 2 to where? To infinity. This is the range of the graph. And you can see that this follows the formula, right? So what is the formula? The formula is minus infinity minus a plus c union a plus c in absolute value to what? To infinity. So this is the formula for finding the range. So let me just show you once again here. This is the formula we're using for finding the range here. Okay. Then the next thing is simply we've seen how to find what? How to find the domain is just what's it's going to be the whole R. It's going to be infinity minus what? All the vertical what? The vertical asymptotes. And what are the vertical asymptotes? The vertical asymptote in general are simply the zeros of the what? Of sign. So it means you have to let sine pi x plus what? Pi over 2 be equals to what? 0. These are the vertical asymptotes. And what does it mean? This means that pi x plus pi over 2, it has to be n pi. Yes, because we know that if sine x is equals to 0, then x is equals to n pi. So from here, you get your formula for x. So you can see that pi of x is just going to be n pi minus what? Minus pi over 2, right? And here, what can you do? You can see that the pi will cancel. You can cancel pi. So x is just what's, you can take pi outside, and you can see it's just 1 minus half. Am I correct? Yes. So this is just going to be half pi, yeah. And then you can use this to be the general. But here, you can see here, since we want to generalize, so let's generalize it. So this is just going to be n, it's just going to be n minus half. Yes, but what is n? N has to be any integer. So this is just going to be minus infinity minus, you can just write it as what? As pi. Pi can go. So once you remove the pi, you just have n minus what? Minus half, where n is any what? Integer. This will give you all the possible vertical asymptotes. All right, so let's go to the next one here. So this one is also similar, but here now we will have to deal with the helper. What will be the helper in this case? The helper will be the graph of y is equals to minus 2 cosine. Here you can take the 3 inside, so it becomes 2 over 3x minus what's, is it pi over 6? Then everything plus 2. So, and here it means that the amplitude will just be absolute value of minus 2, which is going to be 2. The period is 2 pi over k, right? which is going to be 2 pi over 2 over 3. And this is 2 pi over 1 times 3 over 2. This is going to be 3 pi. Correct? Now, the horizontal shift is x is equals to minus b over k. This is going to be what? Minus, then you have minus pi over 2, which is our b, divided by k, which is 2 over 3. So this is going to be plus now. So this is pi over 2 times what? 3 over 2. And this is 3 pi over 4. Okay. Now, let's use another method different from what we did before. We want to find the interval that will sketch our graph. We can just let this guy here to be between 0 and what? 0 and 2 pi. This will also do the job. Instead of dividing 0 to 3 pi into 4, then we add this because this is our horizontal shift. And this is going to say that it is to the right, yes? So now let's work with this one. Here I can multiply both sides by 6. So this becomes 0. If I multiply by 6, this would be 4x minus pi. And this is going to be 12 pi. Right? So if we add pi everywhere, this is pi is less than equals to what? 4x. And this is less than, let's see here. Okay. So this is pi less than equals to 4x, and you're adding, and this is going to be 13 pi. So it means we should start from pi over 4. But let's see this here. We said x is what's 2 over 3, and this is pi over 6. Okay, yes, so something is wrong here. If you look here, what is our b? This is our b here. So b is what? Minus pi over 6, right? So here it's not pi over 2, but pi over 6. So here you have pi over 6 times this one. So this should be pi over 4. Okay, now it's correct. So this is our horizontal shift, pi over 4. And how do I know that there's a mistake? Because here, if you use this method now, when you put the term here, you put it between 0 and 2 pi, your starting point should be the same as your horizontal shift, because this, by the time you divide by 4, you will have this one, and you will have 13 pi over what? 4. So this means that your graph should start from pi over 4, and it should end at what? 13 pi over 4. So this first starting point should be actually your horizontal shift. So I realized that there was a mistake, because using this method, now I got pi over 4 here, but here initially I was having 3 pi over 4. So it means there was a mismatch. So I had to go back to check. And I realized that here I chose the b I used was wrong, because the b here is going to be minus pi over 6, not pi over 2, because you know there is 1 over 3 outside. You have to bring the 1 over 3 inside first before you get your b. And we are comparing this with, so this is our a here. You can check my notes on, you can check the videos in 6.3. We saw how to find our A, B, and also our C here. All right, so let's work with this interval. Now we're going to split this interval into 4. It means they're all positive. So we start from where? Pi over 4. 4 times 4 is 16. 16 times 4 is 24. 24 times 4 is 48. 48 times 4 is 120. 120 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 And we are expected to stop at where? 13 pi over 4. Now, let's see what is the difference between this number. You see, 13 pi over 4, right? The distance, 13 pi over 4 minus pi over 4 should be the period. And what is this? This is 12 pi over 4, which is what? 3 pi. And which is the same thing as the period here. You see, so it means that we're doing well. Now, how do you divide this into 4? One way to do it is just find the midpoint. You add these two and divide by what? Divide by 2. So if you add 13 pi and what? And pi, you will get 14 pi over what? Over 4. You divide by 2. If you divide by 2, is the same thing as what? Multiplying by half, right? And this will give you what? 7 pi over 4. So this is the center. Now you find the center between this and this. So you add 7 pi plus what? Plus pi. This will give you 8 pi over 4. You multiply it by 1 over 2. And if you do that, you will realize that this is nothing but what? This will go with this 4. So this will just become pi. Right. So the same thing here. You add 7 pi and what? And 13 pi. That will give us what? 20 pi. You divide by 4, but you multiply it by half, which is the same thing as divide by 2, because you are looking for the center, right? And this will give us what? 10 pi over 4, which we can split it to become 5 pi over 2, but it's fine. We can work with it this way. Now, where is going to be 0? So it means that we can have our, let's have our y-axis here. Let's assume that this is 0. And also here, you can see that you have a c. What is the c? The c is what? Is 2. So it means we have to locate where is the point 2. This is our point 2 here. So this will be the baseline. Right. Then let's talk about the maximum and the minimum, which we can easily get from where? Which means that we are looking for the what? The range, yeah? So let's talk about the range here. What will the range be? The range, I'm talking of the range for the helper graph, is just going to be minus absolute value for C, then this plus what? Plus C. So this is the range, and this is going to be minus 2 plus what? Remember, our C is 2, so it's going to be minus 2 plus 2, then 2 plus what? Plus 2. So this is like saying from 0 to 4. So it means the minimum value is going to be 0, and the maximum is going to be 4. All right. So let's sketch the graph now. This is the graph of cosine, but we should know that there is a minus here, so it means there is a reflection, right? So the graph of cosine at the what? The starting point. What is our starting point? Our starting point is not 0. Our starting point is what? Is actually pi over what? Pi over 4. So it means at pi over 4, remember the graph of cosine always start from either the maximum or the what? The minimum. So it means at pi over 4, we're supposed to start from the maximum, but because of this minus here, we're going to start from the minimum. And what is the minimum? The minimum is what? Is 2. Right? Then, if we go forward, if we're at the minimum, then you have to come to, sorry, the minimum is not 2. Remember, 2 is our baseline. The minimum is what? Is 0 from the range. So it means we will be here. We'll be at 0. Yes. Then when we're at the minimum, the next thing we should have is what? We go to the what? To the baseline. Yes, we have to go to the baseline because remember we start from what? We're supposed to start from the maximum, then we are back to the what? To the baseline, then to the minimum. That is how the graph of cosine work. But now since we have started from the minimum, then we'll have to get to the baseline first, which will be here. Then we will go to the maximum, which is here. Then we'll go back to the what? The baseline here. Then we will back to the what? The minimum at this point. So this is just going to be something like this. Right? So which graph is this? This graph is the graph of what? Of f of x equals to minus 2 cosine 2 over 3x minus pi over 6 plus what? Plus 2. All right, now you can test. You can always test first before you go ahead. So let's try to test what is f of what? Pi over 4. This is going to be minus 2 cosine 2 over 3 pi over 4, right? Minus pi over 6, everything plus 2. And this will be minus 2 cosine, right? This is going to be just pi over what? 2 here, 2. So it's going to be pi over 6, right? Yes. So it is pi over 6 minus pi over 6 plus 2. Now, what is pi over 6? Pi over 6 minus pi over 6. This is minus 2 cosine of what? 0 plus 2. And you see that this is nothing but what? Minus 2 plus 2, which is 0. And that is as expected. You can see that pi over 4, we are here at 0. So it means this graph is, the helper graph is what? Is correct. Okay. Now that we have checked our helper graph, but we are not interested in the helper graph. We need the sec graph, right? So we already have the vertical asymptotes. So what are the vertical asymptotes? The vertical asymptote are the what? The zeros. Are the zeros, and this will be at which point? This point. Okay, the zeros, just hold on first. All right, so now the vertical asymptotes are actually here. We have to be careful how to pick the vertical asymptotes because already, you know, 2 is like our baseline, right? This is our baseline. So you have to look at where the graph cuts the what? The baseline. So here you can see this curve cuts this at where? At this point. So it means one of your vertical asymptote will be at where? At pi. And another one will be at where? At 10 pi over what? Which is the same thing as 10 pi over 4. So these are our vertical asymptote. So we have only 2 vertical asymptote here, which we are going to use here. All right. So does it? We have only 2 vertical asymptote. Now what we can do is simply, or if you're having confusion with finding the vertical asymptote, what do? Just use the formula. The vertical asymptote will be the zeros of what? Of cosine. So you just need to set cosine of what? The helper graph, which is this one now, 2 over 3x minus pi over 6. You said is equals to 0, right? Now, what does that mean? This means that 2 over 3x minus pi over 6 is going to be pi over 2 plus what? Plus n pi. And now you can multiply. This is 2 over 3x is equals to pi over 2 plus pi over 6 plus n pi. Now you can multiply both sides by 6 so that here becomes 4x and here becomes 3 pi and here becomes pi and here becomes 6n pi, right? So we will have that 4x is equals to 4 pi plus 6n pi. And now you can take pi out the common factor. So you have pi here. And this will just be 4 plus 6n. And then it means that x is going to be pi over 4 into 4 plus 6n. So this is your formula for what? But n is what? An integer. So this is the formula for all the vertical asymptotes, right? And then you can see if you let, for example, you start with what? You see that none of the vertical asymptote is negative. So you can start with n is equals to 0. If you substitute n is equals to 0, what do we get? We'll get x is equals to just pi, right? You see, so this is our first vertical asymptote, which is this point. So it is pi, you see, it is pi, not pi over 4. Pi over 4 is the x-intercept here, but we're interested in where it cuts the what? The baseline. That is seen as your x-intercept because the graph has been shifted to unit up. Now, if you let n to be equals to 1, what do we get? Let n is equals to 1 here. If you put n is equals to 1, you will have 6 plus 4. So you have 10 pi over what? Over 4, which you can see is this one. 10 pi over 4 is this point here. So 10 pi over 4 when you trace it down. And if you try to use n is equals to 2, n is equals to 2, we will have, this will be 12 plus 4, which is 16. So it is going to be 16 pi, right? 16 pi over 4, which is not here because this one is 13 pi over 4. So this one is outside. So we have only 2 of them when n is equals to 0 and when n is equals to 1. So these are the vertical asymptotes. So it means to finish, what will be our graph? Just work with this, the vertical asymptote. This is full here, so you make this to be full, right? This will go this way. Yes or no? Yes, this is what you're going to have. So if you look at this one here, you see this one is half, right? It's not complete, but you can complete this one. How do you complete this one? This is supposed to be completed. So let's assume you complete this side. Let's assume you complete this one like this, right? So if you reflect it, it's supposed to be how? It's supposed to be just like this. Something like this, right? Okay. But now we don't need all of this side, so you can remove this side. So this will just be like this one here. Okay. And also here, if you look at this one, you know, if you continue, you're supposed to come to the baseline somewhere here. So it means this is just going to be something like this. And then let's remove this side. So this is the graph. The purple one will give us what we want. Okay. All right. So I hope it is clear. If you have any question, you can put it in the comment section. And I think that is enough for this one. We will see another video on finding the vertical asymptotes.